easy time using a mobile phone for these things.
You're moron.
Oh no.
Oh man. This guy stinks! Yeah, it's like I would say like people with iPhones, you know, bunch of sheep. But then I don't get like text back because they're like, oh, you're not a blue message person.
Oh no.
What's up, Adelaide waifu? I just got here. Hi.
What the love of God, huh?
I have to call them Adelaide wife. A daily. Wait, is it a daily a wife?
I think it's Adelia.
Adelia wife.
Adelia feels like a.
Sounds like a name.
Like a normal pronunciation.
It sounds like a name.
Sounds like a name.
All right. It does.
Let's go spin the wheel. Who are we gonna win? Who's gonna win? Whose question are we gonna do? We'll see.
Let's go gambling!
I put some new cool things if you like double submit. Wow, breasticle off the rip. Off the rip, dude. Off the rip.
I almost put in the heat equation steak question that I was talking about earlier.
You know what my next strategy is going to be? My next like implementation of the queue is I'm going to have AI analyze the question and I'm going to have it determine the estimated time to complete it. And then from that I'm going to start weighting the questions based on like if you submit a question to me that has an estimated like completion time of like 2 hours.
Oh no.
Guess what? It's not going to be very likely to get picked.
I think you should add one that just like uses AI to comb the internet and see if they're just like throwing in,
you know, if they're just JEE like, questions or just like other trash.
Because like it can do it. I know because I've had it like on some of them when like people submit the JEE, I just throw the image straight into ChatGPT and I'm reverse image search it. You know, scrounge the internet for the text and see if it pops up in a JEE.
Yeah.
Jeff makes a good point. Jeff makes a good point.
They'll ban breasticles.
So you should make it so that it doesn't.
So I'm also thinking about this in terms of like, so I mean, Sensation had a good idea about this, about maybe like we segment the days, just because like some students come in and they want to ask like basic algebra stuff, and they see like nightmare level shit and they get a little scared. So I might like. This is in the future, but what I might do is I might have the AI classify the difficulty level of the question, and then on certain days we'll have it favor like easier questions, and on certain days we'll have it favor like harder questions. Just to like try to segment the audience. But I mean, right now we're okay. But
talk about this later. But I'm still of the opinion you should teach concepts.
Yeah, that's another thing that we talked about doing. I just teach. I could do it. Yeah, that's what I mean. Zach does this. Zach has just like I'm just gonna teach type thing. More streams to add.
Or maybe you could make it look at it and be like, you know, maybe look at it and if it's like, you know, 6 people submit a bunch of like solve the derivative or evaluate the derivative or you know maximize and minimize.
Oh, like it comes up with like a lesson plan. It's like everyone's asking this, just teach this.
Yeah, like if everyone's asking it, make it so that like if someone asks something that's like of a different topic, to like prioritize that if it's already been covered, you know, selected with. Yeah, just because like I feel like every like semester, you know, it's like as you get to the end of the semester, it's a bunch
everyone's
of
asking the same thing,
and at the beginning it's like limits, and then in the middle it's like optimization.
It's the same with Chem. Like we had a lot of titration questions yesterday. You start asking all kind of the same things. Fascinating. Okay, but let's do this one. Okay, this is kind of an engineering question. A rectangular steel billet is placed. Is it billet or billet?
Billet. I think it's billet. I watched a lot of Forged in Fire as a kid. They would always say billet.
The billet has these dimensions where U, X, Y, Z, and T is the temperature inside the billet, where X has these restraints. Cool. The steel is originally at that temperature. The diffusivity is that, and then the heat equation is this. Very cool. All 6 faces are held at forged temperature. U is equal to 1,000 on the boundary. And then what's the question?
The question is to figure out. I forgot to put the question in there. The question is to figure out at what point does it reach
Like uniformly, or when does like when is the peak temperature? Maybe.
What point does the center reach? About 850.
Okay, cool. When does the center? Oh wow! Thanks. Tier 3. Thank you, Broken PH. PH Meeper. Appreciate the subs. You're awesome. Thank you, Broken PH. I need to come up with some cool like tier 3 shit for you guys. Thank you. Okay. When does the center reach? What was it?
I believe it. I want to say 800 Celsius.
Okay. Well, I mean, it doesn't really matter. We can just like find an equation for it, right? Yeah.
Yeah, 800 Celsius. I guess.
Okay.
We'll go with that.
So this is the equation. So this says partial u partial t is equal to alpha, and then I'm going to say like partial squared u partial x squared plus partial.
If you want to save yourself some time, if you just write the Laplacian, the upside down triangle squared.
Ooh, that's another one that works. Yep, you're right. You're totally right. Yeah, that's a beautiful example of this thing right here is called the Laplacian, which is this.
Yeah. Or sometimes in other books they'll write it as invert it, so it's just a triangle.
Okay, so partial u partial t is equal to alpha Laplacian squared u. Okay, cool. And I'm given some initial conditions. I'm given some bounds. So we got to go. We need to figure out what u is equal to based on this. So this is a big differential equation, I guess, right? Or PDE?
Yeah. It's just we'll end up using our separation of variables. First, we have to define a new function though, real quickly. Not like something crazy. Just because our boundary conditions right now aren't homogeneous, and we do need them to be homogeneous.
Okay. We're
just gonna rewrite it in terms of a function v that's equal to u minus 1000.
Okay, so v is equal to u minus 1000, or 1000 minus u.
Yeah, v is equal to u minus 1000.
Interesting. Okay, because I see. Because that's the forge temperature is 1000.
The boundary condition.
That's the boundary condition. Okay.
So now our boundary condition for v is 0.
Okay. So now the boundary condition is v equals 0, right? On the edges.
Yeah.
Okay. Beautiful.
And that's helpful for us because we do need the homogeneous boundary conditions. And since we're taking the derivative, the equation in and of itself, or the PDE in and of itself, doesn't actually change at all.
Okay. Yeah, because this is all constants. Right?
Yeah, exactly. So it just drops out.
All right.
And
so
then we also want to figure out our initial condition as well while we're here, which would be
our initial condition
XYZ.
is v of xyz is equal to 0, no? Or no, it's equal to 25.
No, u of xyz comma 0 is equal to 25, but since we're subtracting 1000, it's going to become negative 975.
Got you. Right. But if that equals that, then v of x, y, z, comma 0 is equal to negative 975. Okay. I agree. Cool. All right. What do we do next?
So now we can start by doing what's called separation of variables. I think I've showed you kind of what it is.
I do like separating variables.
Yeah.
I can do it with simple derivatives.
Well, so it's not even not like the separable ones where you move it over to the other side and stuff. In PDE, what we call separation of variables is a method of solving. You can do like wave equation, Laplace equation. You can use basically any equation. But what we're going to assume is that v is of the form x of x times y of y times z of z times t of t.
Okay. V is equal to, sorry, x sub x. Is what we're saying? Yeah, I got it back.
X
Sensation.
of x as like a x,
Oh, okay,
a
okay.
big x and a big y and a big z and a big t. And
Okay.
their
Plus
functions
big Y of Y.
multiplied.
Oh, all multiplied. Oh, uh-oh. Okay, I guess so. Someone's asked, this is PDEs, I'm pretty sure, is what this is.
This
not a Shindo. Or metallurgy, I guess, is the other thing we're saying. Sorry, who in YouTube chat was telling me things? My bad, sorry, I didn't have the chat on. When was the last time I worked out in the last decade? I worked out about an hour ago. Yes, the algebra does suck. Okay, cool. All right, so we're here. Yeah.
And then t of t as well.
Times t of t.
Yeah.
And then am I gonna take derivatives?
Yeah, you'll end up taking your derivatives and then substituting back in.
Okay, so let's do dv dt. That's the easy one, right?
Yeah.
dv dt is literally just this. And then times d
T
times
prime
d
t.
yeah, times t prime t. Which, yeah, okay. I guess we could like do this, right? Okay, this one kind of sucks though. This is gonna suck. It's gonna suck.
This guy stinks!
Okay, cause let's do the first one. So let's just do. Let me remember. So lambda squared is nabla squared is the same thing as lambda dot, right? This of like whatever.
Well, and the easier way to think of it is that nabla squared is just the sum of all your spatial derivatives.
In the second, it's the sum of all of my spatial derivatives, but after the second derivative, right?
Yeah, they're all the second derivatives.
Right. Okay.
I mean, it looks worse than it is.
Yeah, because this first one is right. I'm going to take the partial of this with respect to x, and that's going to be a component, and so that's going to end up becoming x prime of x, and then times the rest of the stuff, right?
Yeah, and we could just straight jump to the fact that it's going to be x double prime, because those are just constant with respect to
right.
x.
These are constant with respect to x, so it's going to be this, just to show people like how this works. Because nabla, I think I always like to describe is kind of like a super derivative. It's like a super spatial cool derivative, right? And then this would be, and this, and the z. What am I looking at? You're looking at partial differential equations, Mike. You are looking at your TV screen or your phone screen or whatever. Okay.
You're looking into your soul.
You're looking into your soul.
Oh no.
Oh no. So there you go. That's nabla. But then I dot that. So I'm going to do another derivative of each one by component, and then I'm going to add them all up together. So that's going to become x double prime of x times all of this, right? Plus y double prime of this times the rest of it plus z double prime of all this. You're just interested because you're interested? Yeah, no, I'm glad you're interested, Mike. I'm very glad you're interested. Yeah, welcome to the party, dude. Okay, so this is nabla squared of v is equal to this, which I think I can simplify, right? Or no, I can't really simplify.
Yeah. So, once you substitute that into the actual equation, we can simplify it pretty easily.
Okay, well, let's try and do it. Okay, so dv dt is equal to this. And then, so wait, I'm essentially doing this, but doing v instead of u, right?
Yeah. Just because in that case, our u doesn't have homogeneous boundary conditions, so we can't solve it. But we can just make our boundary conditions homogeneous by doing that. And even if it wasn't a constant, say our boundary condition was like just x, x or x squared. You could.
Sorry, what are you talking about? Like, sorry, you said homogeneous boundary condition, right? Is that what you said, right?
Yeah, it has to be equal to 0 at the boundaries.
That's what okay, so homogeneous. Okay, I get it. You mean like with a homogeneous differential equation? Yes, it has to be equal to 0. So in my mind, like homogeneous boundary condition just means that it needs to be the same. But I get it. You're talking about like in the diffie-q term, homogeneous usually means equal to 0.
Yeah. We want our boundary conditions equal to 0. And a lot of times that's just a very easy substitution by saying, okay, let's have a different function and just
got it.
Boundary conditions.
Thank you, Lone Wolf. Got it. Breasticles will have a good stream. I know Breasticles gonna have the best stream.
I think I will.
Yeah. Have you finished moving into your place yet?
No, not yet. It was midterms this week, so I was focused on that and not moving.
Oh yeah. You said you had a proof final today or something.
No, I had yesterday. I had a computer architecture midterm. That was the most fucked up test I've ever seen. Granted, I was more familiar with what was on the test than what was supposed to be on the test. But the dude spent about a week and a half preparing us by going over last semester's test, and then proceeded to not put any of that shit on this test and just throw random shit that we did like
rude.
Like 2 weeks into the semester.
So rude. I
I
literally had a parent call me yesterday, or maybe the day before yesterday, asking me to like tutor their kid, and I was like, well, I don't really tutor anymore because I'm so busy with this and everything else. And they said, well, money is no object. And I was like, okay, wait, you have my attention. You said money is no object. Anyways, they described something that I think is exactly what you described, is that like, you know, their child is pretty smart, their child did all the practice exams, did all the homework, but then they got the test and it was nothing like they'd ever seen, which I think is terrible. And I understand that like some professors do this because they have like, it comes down to like an empathy thing. Professors have been teaching for so many like decades sometimes that they assume all the students who are seeing stuff for the first time have the same holistic, complete understanding that they do about the topic. So
truthfully, I don't think this dude has an understanding of it. I'm gonna be 100%.
Okay, maybe he's just dumb too.
Yeah,
so like he doesn't even know like the difficulty of things being asked. But
last time we were talking about like a not C code, machine language, MIPS. And he's like, well, what's the function of this code? And I'm like, and it was just adding up multiples of 3. And I go, I raise my hand and whatever. He calls on me, and I'm like, it's a summation from n equals 0 to n equals 10 of 3n. And he goes, no. And then some kid up in the front goes, it's adding multiples of 3 up to 30. And he goes, yeah. I'm like, dude, that's exactly what I just said. And I can, on paper, write that in about an inch and a half, 2 inches.
Yeah.
And he's like, well, those too many words. And I was like, no, it's
too many words.
It's literally, I was like, it's literally like a couple of letters and a couple of symbols.
Yeah, chill, dog.
Like, what?
Femvox says, when the teacher throws a crazy curveball like that, the silver lining is that all students are equally surprised. Yeah, correct. I like to think that teachers sometimes do this because they're testing for the savant. They're testing for someone who is like already taken the class, right? So maybe they're like retaking it, and so they're able to apply the stuff from practice tests and the stuff they learned towards doing completely new stuff they've never seen. Or, again, they just really love this shit and they're really smart and they can do it. But for the majority of the class, if you give a student something that they've never seen before, they're just going to panic. They're going to panic and, like, they're not going to do it. And, like, everyone gets a bad grade. So, and then everyone feels discouraged and everyone thinks they're really dumb. And then their parents are calling me saying money's no object.
Well, the problem, too, is that, like, he told us that it was going to look just like the midterm from last semester. And then it didn't. Like his last midterm,
he's a liar.
The low score was a 15. The high score was 120, and the median was like a 60 or a 65. Which is like
that's all over the place. Yeah, that's a bimodal distribution.
Yeah.
So yeah,
makes sense.
I understand. It happens. Okay, let's finish this. All right. So we got this. I think I can start canceling some stuff out. Well, almost, right?
Yeah,
the problem is, like, I don't have, like, an x of x over here, right?
kind of. You'll also want to multiply by alpha as well. Right.
Oh, I forgot
there's
alpha. I
multiplied
forgot
for the
alpha. Oh, I forgot
50%.
alpha.
Yeah.
Yeah, there's alpha. Okay. Alpha?
Yeah.
Yes. My fish.
Mhm.
Okay.
All right. So you're actually just going to want to, it's a pretty simple move. You're just going to want to divide by alpha of XYZT.
On both sides?
Yeah, on both sides. Because see
Okay.
how there's a like XYZ for the T prime term, there's a YZT for the
Yeah. Yeah, one of them
all
is
of
going to
those.
survive.
Yeah, exactly.
Yeah. That's what I figured. It's kind of like partial. It's like, what do they call it? Like partial. Dude, can this move, please? Partial fractions, I guess, maybe. It's kind of like it. Okay, we're going to divide both sides by all this. Oh, if I could.
And then T.
Oh, XYZT. Oh, sorry, I need the T as well.
Yeah, all of it.
T of T. Okay. Okay, so all of this now goes underneath this. Okay, and then let's see what we get. So on this side, cancel. So I'm going to just get T prime of T. We're going to say 1 over alpha. And then T of T equals, okay, then let's see what happens here. So, right, yeah, the Y and the Z will cancel with the Y and the Z. And then, oh, the T will always cancel with the T. Oh, so I'm just going to get, whatever, the double prime. Oh, the alpha's going to cancel too. That's nice.
Yeah.
So I'm just going to
Alpha
get
cancels and you get
X
alpha
double prime
times.
of X over X. X of X, sorry. And then we're going to get plus Y double prime of Y over Y of Y plus Z double prime of Z over Z of Z. Right?
Mhm.
Okay, perfect.
And then this is where it gets nice and how the main idea of separation of variables works is that we can say that all of these are equal to some constant and just evaluate each differential equation, right? Because the thing is
Oh.
that if we look here, right, we're taking a derivative with respect to t.
Yeah.
We're taking a second derivative with respect to x, with y, with z. And so
Yeah.
what that means is that they all have to be equal to some constant.
What, sorry, why do they all have to be equal to some constant? You're saying like this is equal to A, this is equal to like B, this is equal to like C?
No, they're all going to be equal to a lambda.
Oh, the whole thing together is equal to lambda.
Yeah, that's equal to lambda.
Okay. And
Right.
that's a constant
Because-
because why?
Because if we're taking our derivative with respect to t, the only way that it can be equal to a function, right? Because that t of t is only a function of t, right? X
Correct,
of x
correct.
is only a
Okay,
function of
okay.
x, y,
Okay.
so on. So the only possible way that they can be equal to each other is if they're equal to a constant.
I see, because if this is a function of t, this is not.
Yeah, exactly.
Maybe. I guess you still could have t's in here though. No, couldn't you? Or is this
No, 'cause
this means
the-
it's only a
that's
function of
saying
x?
it's purely a function of x.
Ah,
that's our,
okay.
Our initial assumption when we do separation of variables is to
Yeah.
assume that it's of that form where
Got you.
everything's a function, right? They're just products of each other, and
Got
everything's
you,
just
got
a
you.
function of t.
Right,
function of
otherwise
x,
the
y,
partial
this
derivatives
thing.
wouldn't make any sense.
Yeah, exactly.
Okay. I see what we're saying. So we're saying that when we made this assumption right here, this is strictly only function of x, this is strictly only function of y, strictly only a function of z, strictly only a function of t, so that when I do this behavior right here, I'm not taking derivatives of y, z, and t when I do d dx, because I'm assuming that these are constants compared to x.
Mhm.
Very cool. Okay.
Yes.
All right.
Yeah,
So,
that's
okay.
how it works out.
Right.
easily.
Okay. So in order for these two things to equal each other, they both have to be equal to some constant lambda.
Mhm.
Okay. Cool.
And then, since we're working in 3 dimensions, right, we can just solve by saying, right, say like lambda sub y, just to show that it's right for the lambdas that there's a component. Also, I forgot it should be a negative lambda.
Okay. Cool. All right.
All right.
So what, am I gonna just set this equal to this, and then
easiest-
this is e to the alpha t
Yeah.
or something, right?
That will get you, yes. Yeah.
Right. All right. I feel like it will.
Mhm.
Okay. So if we do this,
Yeah, it would.
we're gonna get 1 over alpha. I'm just say like t prime over t is equal to negative lambda. This is a very well-known differential equation, which is just that e is t of t is equal to, I think it's e to the negative lambda over alpha t. No, it has to be e to the lambda alpha. Yeah. Alpha lambda. Or lambda alpha.
Yeah,
Like that. Because if I take the derivative of this, wait, but that'll pull down a negative, right? Oh, okay, and there's the negative. Okay, great. Yeah.
that's
Okay,
fair.
cool. This is good. Okay, I agree with this. Okay. So then we have to deal with this. This part right here, right?
Yeah.
Look. Is that going to be e to the negative lambda xyz t?
Yeah, so what we can do is, each lambda
I
is
got
going
3
to have
components.
components, yeah, but we can just, write out, right, x double prime plus lambda and just use like a subscript to say like lambda
Okay.
sub x, lambda sub y.
Am I going to assume that lambda is equal to lambda sub x plus lambda sub y plus lambda sub z, or is it multiplied?
It should be all plus.
Okay. I'm going to say that it has components that add to each other. Okay. So t decreases as t increases. Well, that also has to do with this, though, right? So, Femvox, we defined that v is equal to u minus 1,000. So, technically, as this goes up... Well, I guess v does go down. Wait, no. As v goes up, u goes up. Yeah. I see. Femvox is saying that as time advances, the time-dependent component of the temperature goes down with the negative lambda.
No, it doesn't go down because it's e to the negative lambda alpha t is still going to increase. It's just going to start to increase slower, which makes sense, right? If you imagine like heating
wait,
something up, so
Wait.
yeah, because it's an
E to the negative x.
it
E to the negative x looks
never
like this.
decreases.
E to the negative x looks like this. No, am I crazy? I feel like I'm not crazy.
Yeah, no, yeah, you're not crazy.
I'm not crazy. We love that.
Hold up.
Maybe lambda's negative. We don't know yet. I mean, I could have set this equal to positive lambda, and then positive would have worked as well. But then temperature would grow exponentially.
Yeah, the problem with setting it to positive, mostly in lies are spatial derivatives, right? Because we have second spatial derivatives. The purpose behind making lambda negative in this case is that separation of variables leads pretty easily into a Fourier series, right? Because when you solve that, you're going to have a component, right, for your sine.
Okay. Let's just keep moving.
And then
We'll see.
that's
Let's just see.
Works.
So this is what we're
works.
saying, right? This is just like one of the components, right? X double prime of
Yeah.
x over x of x is equal to negative lambda x. So,
And we can just solve that DE.
yeah. So I think that's that's x of x is equal to. Fuck. What is it?
It would be
Is it the square root?
A sine. Yeah, and that comes from our characteristic equation, and we can just say that lambda of x is, we normally call it mu squared.
Oh, okay. So like this maybe. Or
well, lambda of x would be the square root, and we call the square root mu squared.
so like that.
No,
Yeah.
mu. We call the
Oh, you're calling this thing.
no. Instead of saying lambda x, right? So it comes
Yeah.
from our characteristic equation. So it would be I normally use lambdas when I do the characteristic equation. Say like a squared plus a is equal to 0 for the characteristic equation.
Okay.
So we get square roots.
Okay.
Right, so we say that lambda is equal to mu squared.
Lambda is equal to mu squared.
Lambda sub x.
Lambda sub x. Okay.
That way our characteristic equation works.
Boom, boom, boom. Oh, wait. I think I see what you're saying. Sorry. Right.
Yeah.
You're solving
move
this
the
by
x over
multiplying
to
this.
the-
Okay, one sec.
Yeah.
Okay, I get it now. You're saying this plus lambda sub x, x of x, is equal to 0. Right, and then this solution is, what is this? This is like a squared plus lambda x a is equal to 0. And then solving this,
Oh, I don't think there's a there on the second term.
oh, sorry. Lambda x. Well, yeah, no, you're right. There isn't.
It should just be because it's
Yeah, it's just this. It's just this.
A is
It's this. Yes. Okay. So then a is equal to plus or minus the square root of lambda x. I see.
Mhm.
So then a squared, right, is equal to lambda x. Okay, but you're gonna call this mu. You like calling this mu.
Yeah, that's normally what we do in separation of variables. Well, no, call lambda sub x mu. Oh,
Yeah.
no, I see what you did there. Yeah, that's fine.
Yeah, I think it's this is what you're saying. And so you're saying mu squared is equal to lambda sub x.
Yeah.
Okay, and then yeah, this comes from if you say that like x is of the form e to the mu x. X of x is e to the mu x. Right, okay, cool. Yeah, this is just regular differential equations. Okay. So cool. So now I know that x of x is equal to e to the mu x, right?
Yeah, but it's complex. Right. There's a e to the I. This is one of those cases where we would say it would be sine and cosine.
I see. Oh,
So
okay.
we'd say x of x is equal
I see,
to a
because
cosine.
when I move that over, it's plus or minus the square root of negative lambda. Got it. Okay. Oh, thank you. Okay, cool. All right, yeah, okay. So this is a sine and cosine
Mhm.
solution. So I'm gonna say x of x is equal to, I think it's mu. Is it not mu?
It's a cosine of mu x plus b sine of mu x.
Right, where these are constants.
Yeah.
Gotcha. Okay, cool. All right, cool. And then it's the same thing for y and z, right?
Yeah, works out.
But those are
there.
different constants. So it's like c cosine mu y plus d sine mu y.
Yeah, I mean they all the constants end up working out to 1.
Okay.
Or 0 respectively.
Okay. All right.
So
now we have our x, y, z. We have our t.
Our yeah. So we plug in our boundary conditions. And then when we do that, we'll get that the cosine terms cancel. Or well, not cancel.
Okay, so these were our boundary conditions.
Mm-hmm.
Uh-huh. But we also set the boundary conditions such that this is for v though, right? Oh, here. So this is equal to negative 975, right? Or no, v equals 0 at the edges. Right?
Yeah. V equals 0 at the edges, so we're gonna use the boundary conditions for v.
Got you. Okay.
Which is at the edges, it's 0.
V of 0 is equal to v of like 0, 0, 0, t is equal to 0. Okay.
Mm-hmm.
Okay. So all the cosine terms die?
Yeah, in essence, basically when we I'll save you like
Goodbye.
the algebra, because we don't spend a ton of time with the algebra. But yeah, when you plug in at x equals 0 and x equals 0.3, and you plug that into b0, the cosine term dies off because we get that a is equal to 0.
Okay. So what do we get from here?
So from there, we also get that when we plug in 0.3, that b sine of 0.3 mu is equal to 0. So we can say that 0.3 mu is equal to m pi.
Yep. Right. Because I need the sine of it to be 0. Yeah. Okay, cool.
Mm-hmm. And then you can just get that mu is equal to m pi over 0.3.
Okay. Yeah, that's kind of like the periodicity of the. All right.
Mm-hmm. And then you can just plug that straight into your
Okay.
x of x equation.
Yep. Okay. So spatially, now we have b sine of
b is equal to 1.
what? Ooh, why is it equal to 1? What? Where do we get 1 from?
More plug in boundary conditions.
We plug in more boundary conditions. We get is equal to 1. I'm curious where that comes from. What other boundary conditions?
Because we're saying that b sine of 0.3 mu is equal to 0. It doesn't really matter what it is. So
sure. So why doesn't b equal like 69,420 or something?
It could equal anything.
Okay, so we're just gonna also assume b equals 1.
Yeah, we basically we get to
this is some hand wavy shit, dude.
The constant will come back up in the Fourier series. It'll be fun.
Okay, fine. All right. So spatially, evil math. Yeah, I know. A little scary. Z of z, that's gonna equal to. Okay. Sine m pi over 0.3.
Times it should be m pi x. And that's just for the x sub m. For the Fourier series, right? We say x sub m of x is equal to sine of m pi x over 0.3.
Oh, I forgot the x is in here. I forgot the x is in here. Yeah, save me some algebra because like my my strength is wearing here. Once we've made it this far.
Yeah,
like,
x, y, and z equations, it does the same thing. So
okay.
You just get like another sine, and it's so sine of m pi x. Your variable changes to like n and then p as well.
Gotcha. Uh-huh.
And then our coefficient on the y and z also becomes 0.1 instead of 0.3.
This changes to 0.1?
Yeah, because in this case, right, the x value is 0.3, but no, the one for x is still 0.3, but the other two change.
Oh, the other ones had different. Yes, yeah, I get you. The other ones had widths of 0.1.
0.1 instead of 0.3.
Got it.
Yeah.
Okay. Okay.
4 days later.
Yeah. I am gonna have to start putting restrictions because this has been 40 minutes on this question. Is there a quick part? I'm looking at the time. It says 40 minutes.
40. Looks like it's been more than that.
It's been 40. Yeah. Well, we had a little bit of an intro. Again, this is cool, but I just don't have an hour on a stream to go through this.
Yeah. So after that, you would just write as a Fourier series.
Okay. We're gonna say that
constants, but
right is Fourier.
We've done the brunt of the calculation at this point. After that, it just becomes some basic substitutions. So you inevitably get to
yes. Let's say like done. Finally. There we go. What do we got? Oh, wow. M and P is equal to 1, and they're odd. Okay, interesting. Where lambda is equal to that. Do you have to do this in university? No, never.
Oh no.
No. Okay, cool. And then you could just you could plug in values for x, y, and z,
values and
then you can solve. So here's my question: actually, would you set m and p equal to just 1? Oh no, this is the summation from 1 to infinity. Oh, you have to go through all the modes.
Yeah, well, so what that is it's the superposition, right? So we're saying that we get that function, but we don't really have a specific m and n value. So you could take the superposition of it for the Fourier series.
Of all the combinations, dude. There's so many.
Yeah, there's a lot, but it's just it's 1, 2, 3, and then you could plug it in. Really, you could just approximate it with a couple of substitutions, or you could have ChatGPT do some stuff. Generally, it approximated it to the function for the center of it. It said u center of t is approximately 1000 minus 2012.5 times e to the negative 0.0244 t.
Okay. Cool.
Okay. Which is approximately.
I'm glad this one is done. This was fun. I can't wait, Breasticles, for you to have your own stream so that I can come bother you about this on your stream.
Yeah.
See, this would be great because again, I am learning a lot through this. It is great. We need a dedicated channel to that, a dedicated session to it. Yeah, it's cool. I love what you're doing. It's great.
I could have more time to
Oh, I would love to take. I would love to take more time to learn about the actual Fourier part. I'm kind of bummed that I don't get to see it, but also we would be here all fucking day if we did.
Well, the part going to the Fourier series really isn't that
Yeah, but I want to understand it. I like the walkthrough,
Yeah,
but,
I mean, for the most part, it's just saying by superposition, throw a summation on top.
It's cool. Okay, let me choose a winner for you guys. Let's see who's the next one.
Let's go gambling!
Someone give me something nice, please. Something nice. Please be nice to me. Gladiator, it's you. Congrats. What do you got for me, Gladiator? Probably Chem.
Gladiator's probably here, but I was just going to say you probably might want to make sure they're actually here still.
They They should be. Gladiators chill. Gladiators chill. What's up, Gladiator? All right, let's see. All right. Sketch a fully... The one non-math question in the queue, Grumble.
My name is Jeff.
Jeff's so upset. Jeff, you didn't like the math question Brasicles put forward? That was pretty fun.
Yeah, I just gave like a beefy ass math question.
Yeah, that was so much math, dude.
Like,
yeah, what? You can't tolerate like some baby chem? Okay. Sketch a fully labeled potential energy diagram for the following reaction mechanism. Be sure to label the axes EA, delta H. The delta H for the all reaction is minus 2 kilojoules. Also calculate delta H2 as well as EA1 reverse. Okay. Activation energy is usually like the hump you have to go over. That's what I think about. So... let me think. I know it's going to be something like this. Where do I put the different reactions, though? I got to go to the internet. I got to go see. This is what I want. Yeah, see, I want something like that. I know what it looks like. Here's my question, though. Oh, they just say reaction proceeds. That's how they do it. Okay. It's like a time axis, I guess. Transition state, products. Yeah, but this has 2 states. So we want something like this. Yeah, there we go. That's what I like. I like this. This is what I want. Okay. Activation energy is 11 kilojoules. Delta H is equal to 5. Activation energy, I think, always refers to the energy needed to get over the hump, and then delta H is, for instance, from here to here. That's delta H. Okay, so let's do it this way. So I think this is what happens first. And then they said the overall delta H is -2. Okay, cool. So I know what the final is. All right. So let's say this is the final thing right here. The final reaction is going to be NOBR. NOBR. And then the initial thing we're starting with is going to be two nitrogen monoxides acting with each other. Okay. And then I need the this is not going to be drawn to scale, but the difference between these two needs to be -2 kilojoules. Yeah, there we go. Between that and this. Okay. So, NONO goes up to become N2O2, and in the process, has a total delta H of 5. Okay, so that's going to be something like this, I would say. Here. And then this state right here, this is the N2O2. And then we could draw this, I guess, if we wanted to. Let me put like green. Yeah. Or maybe, here, let's do it this way. I think we should do it this way. Yeah. We're going to say that this jump here is 11 kilojoules. That's the activation energy. And then delta H going up by 5 tells me that from here to here is going to be 5 kilojoules. Okay. And then from this needs to have an activation energy of 8. So it's going to go up even more. And actually, here's the cool thing. So if this started at... Let's pretend that this starts at 0, right? This is 11. But then a net gain of 5, right, means this is 5. So going up 8 is only going to take me up to 13. And then it needs to come all the way down here. Bro, I just passed my physics 1 for engineer with a B+, low-key rough as fuck. Congrats, dude. I'm glad you passed. B+ that's a noble grade, dude. Very noble grade. Okay, sorry. This is what I want. I just want this to like look nicer. There we go. Okay, cool. And so we're gonna say from here to here, that's gonna be equal to 8 kilojoules. And then here's the cool thing. The overall reaction is -2. So this is going to get up to 5. This is going to get up to 13. So delta H has to go from being up 5 to eventually being down 2. So X in this case is going to be equal to -7. Or, sorry, yeah. So delta H2 is equal to -7 kilojoules. Oh, which they wrote, yeah. Yeah. And yeah, the reason for that, right, is so if you go up 11 but end up at 5, now you're at 5. Going up 8 is going to get me to 13, but then I need to come down to -2. So this difference right here this delta H2 is equal to -7. Whereas this is delta H1 here. It's like delta H1. There we go. Delta H1. There is equal to that. This is not to scale. And then EA1 reverse. Okay, very cool. Okay, EA1 reverse. So, okay, that's going the reverse from here to here. So that's going to be, 6. Because you're starting at 5, you got to get up to 11. Right. Yeah, and then EA1 reverse is equal to 6. Because you have to go from being at level 5 to get over the hill at 11. So you got to go up 6. Yeah. Okay, cool. Yeah, I knew it was something like this. I had to just like kind of like just see it. But this is also a very useful diagram right here for how this works. Cool. Does that make sense, Gladiator?
Good job.
And then you'll learn later there are really cool things called catalysts. And catalysts are like cheat code shortcuts. And so what they do is they lower the activation energy. So they provide like a way for you to like take a shortcut like through the tunnel. Some very famous catalysts, right, are like platinum and like catalytic converters and stuff. Yeah, sometimes they take you a while. Okay, cool. All good. Yeah, just always draw it out. And then just, I find like marking your starting as like kind of 0 per se. And then thinking about things in terms of like where they are on the y-axis will help you out. Yeah, it's good.
The amount of time that it takes you to perform an action doesn't make you stupid.
The amount of what it takes you to... Sorry, what? The amount of what?
The amount of time that it takes to perform an action doesn't make one inherently stupid.
No.
What makes one inherently stupid is bad English.
Oh no.
Unless you're a foreigner, and then...
Unless you're a gaijinko. Gaijinko?
Guy Kokujin.
Guy Kokujin.
Outside country person.
Outside country person. Guy Kokujin.
Literal translation.
Guy Kokujin. Nice, Gladiator. Cool. Alright, there's Gladiator's question. Good job.
But yeah, so everyone needs to sort their English out like now, or else you're just gonna be fucked by it later on, like for real. You will at some point have to unlearn the things that you learned. And it's a whole thing, because I had to do this.
And now he's a proper reform person.
Well, no, but the point is my colloquialisms are less. And I don't know, it's kind of weird. It's like, it opens your mind a bit more.
To not, like, be stuck in the short speak of things.
The words that you employ alter your perception as to the world. It's very strange. It's like if you're a thicko and just like going to the pub and it's like, hey, up, guys, you off to the pub, but fucking get pints in, then and then you all start talking all academically. It just fundamentally shifts the way that you perceive the world.
I like it. No, I think that's a great argument. I mean, honestly, again, I'm very much a math and science person. I was absolutely awful in my English classes. But I do see the value in it. I especially notice it if I'm like texting a girl or something and like she's using the wrong version of there.
Oh no.
I'm like, oh no. Oh no. Oh no.
No,
No,
I just, yeah, that's.
just instant block. No, but seriously, like people will like judge you based on your spelling. I have one friend, who just like never spells things right, and it's always like the biggest burn, right? When they're like trying to like shit talk you, and you're like there, and then you put like the asterisk, and you're like, you fucked up, dude.
I can't find that image fast enough, can I?
Yeah, where are you gonna go? You're gonna go find it. Sensation's gonna get mad when he hears the Toronto accent.
I remember my ex got really pissed at me one time. When I
as one does.
dumped her. I think it was the second time.
You dropped her twice?
Oh no.
Yeah, we dated.
My boy.
She was like on some weird shit, and I was like, whatever. Like, if you're gonna act like that, I'm gonna like stop. I dump you.
This is so good.
Well, apparently, I never like unadded her on TikTok. And she saw a repost. I had it reposted, and this person was like, "Oh, if you're talking with my ex, don't be proud. She talked to a dog if it will give her attention." And apparently she saw that repost. She screenshotted it, added me on Snap, and then asked if it was about her, which it 100% was. But I lied. I'm like, nah, whatever. And she's like, "Oh, well, I really miss you." And I was like, "Fuck it, like." Let's see if she's on some weird like tweak shit again. And she in fact still was. So I dumped her, and she was like, "Oh, I don't want to lose you," but she always spelled loose.
No, she spelled it loose.
And and so I went, "Well, technically you didn't, because that's not how you spell lose."
Oh my god.
Oh no.
And that one kind of pissed her off.
Yeah, that'll sting a little bit.
I didn't really care.
Okay. Right. Y'all should speak English. Yeah, listen to Sensation. He does it because he loves you guys. Yeah. I know some people are like, why is Sensation being so mean about the English? It's for your own good. It's for your own good. You need it.
Well, it's not like I'm even sitting there talking about esoteric shit. It's just like, basic things. I mean,
English.
there's no reason anymore to use those kinds of contractions like you and are and things like that, because you have unlimited texting capability.
Yeah.
They don't have a modern purpose anymore.
They don't have to do it. Oh, you know what's actually cool? I forgot to show you guys. Okay, so on the queue system, so very cool. So there's a lot of really cool stuff I built into here. So you'll see the votes, right? Those are accumulated based on your time. This right here is the rate at which you're gaining votes because of how long you've been waiting. So if you've been waiting over 45 minutes, I think it goes to 240. And if you've been waiting over 90 minutes, it'll go to 360. This is a way to like make sure people aren't waiting forever. The supers is how many times you keep hitting the upvote. And then, so I have a lot of like cool diagnostics so you guys can see stuff. Yeah. Machka says, spin the wheel. All right, let's go spin the wheel. I'm sorry. Yeah, I'll pause the apping. Let's go spin the wheel. Let's go gambling.
Let's go gambling!
Trigonometry Boy says, I need help with 6A. We'll see. We'll see if we get you.
Leo says it's the fast typing.
It's the fast typing.
No, you see, because that's one of those things. It's like one of those things you have to unlearn.
Yeah.
It should be faster to type fully, normally, because of muscle memory. And so the muscle memory that is employed currently using contractions is the wrong kind of muscle memory. So you have to unlearn that to relearn how to do it properly.
Yeah.
Later on,
Well, you also got to consider, like, these days, like, if you're texting someone, your phone will look at the context of your message and autocorrect to the right your.
It will actually.
So, right, I mean, granted, I can't criticize too much because I usually just use UR when I type, but it will autocorrect. So there's no reason.
You were right.
you should be typing the
Jeff.
wrong or when it will literally fix it for you.
Yeah.
Like,
Yeah, you have no excuse. All right, what's up, Nathan? What's up, Tumo? You need help with this one? What's up, dog?
Yes. How you doing?
Good. Can you boost your mic a little bit? It's like a little soft. You like shove your mic closer to your mouth.
Is this better?
That's much better.
Okay.
Eat the microphone.
Use the microphone.
Taste the rainbow. Okay, find the equations of the tangent lines at the point where the curve crosses itself. Wait, the curve crosses itself? Oh, so like where it hits the same point, I guess?
That's what I was trying to figure out too. But I think so.
Okay.
I can show you a reference picture.
Yeah, show me a reference. I mean, I could graph this. I could fucking graph this, I guess.
Probably.
You might have to boost him a little bit before that.
Yeah, I have him maxed out on Discord already. Oh, okay, I see.
Or
He's talking about something like this.
yeah, or something like this as well.
Uh-huh. Okay, yeah. So where it hits itself. Mm-hmm.
Why are you hitting yourself? What? I'm just
Why are you hitting yourself? Why are you hitting yourself? Okay, I see what we need to do. We need to find a place where x equals the same. We need to find a value of t such that x equals itself and that
like
y
it's
also equals
the x
itself.
is the same as y, right? Like it's the same x value.
Well-
I don't know.
Well, no, x is not the same as y. It's like, okay, here, let me sorry, before I removed that. Okay, so for instance, all right, I assume this had the orientation that it was like going this way, right? So this could have happened, yeah, at t equals 2, or sorry, I guess this would have happened at like t equals -1, and then as t advances, eventually it hits the same thing at t equals 2. So do you see how the x for two different t's is the same, right? X is equal to 2 when t equals -1 and t equals 2, and it's also equal to the same y when the t's are two different t's. Okay. So, here's the issue, is I immediately I'd want to just say that, like, this is periodic, right? Because, oh, okay, I think I see what we're going to do here. And also, they gave us restrictions. Do you see how t has to be between -pi and pi?
Oh, negative pi and pi?
Yeah, do you see?
It's like a 180? Or no? It's like a full 360.
Yeah, it's a 180. Yeah, it's from... No, it's a full 360. What the fuck am I saying? Yeah, it's a full 360. Yeah, Jeff has it right. Okay. So what we're going to do is we're going to define two different t's. Find the equations of the tangent lines. Whatever. Let's just figure out where it crosses itself. So we're going to say like t1 is where it crosses the first time, and then t2 is where it crosses the second time, right? And we need the x value at each of those times to be the same, right? So x of t1 needs to equal x of t2. Does that make sense? Also, y of t1 needs to equal y of t2, yeah?
Yeah. My first instinct was to make a t table where you have like points from 0 to 2 pi.
Sure.
And, like, you know, is that like the right approach?
No, because you're going to get fucked here. The issue is that, so, what, you were going to choose like pi over 4, pi over 6, pi over 3?
Yeah.
Yeah,
Something
I
like
mean,
this. Like, yeah.
that would work. The issue is this is going to mess you up. Yeah, no. That's like kind of, that's okay if t was only in the trig function, because, right, cosine and sine of those values will get you like zeros and ones and stuff, but then you also have t on the outside here, which is going to mess things up.
You done messed up, Aaron!
Right.
Yeah.
But you may be right. I think what we want to do is we just want to set this up. So, for instance, I want to say, okay, so 2 minus pi cosine of t1 is equal to 2 minus pi cosine of t2. And then I'm also going to say that from the y condition that 2t1 minus pi sine t1 is equal to 2t2 minus pi sine t2. Okay.
Yeah.
So some cool things that come up right away, right? This cancels with this.
Right.
Then minus pi cancels out with minus pi. So I literally see that, oh, okay. Cosine of t1 has to equal cosine of t2. Okay. And in my eye, like what that means on a unit circle is I need like basically like two of these. Right? Do you see how like the cosine of this angle is the same as the cosine of this angle?
Yeah.
But they're gonna have different signs. And that needs to happen here because now T1 and T2 have escaped the trig function. Okay, let me see. Move 2 and 2t to the left-hand side and square both equations. Yeah, maybe. Here's what I'm thinking about doing. Okay, I know this is true. I think there's some sort of identity around that then.
I'd give the tables a shot.
I think the tables are going to work because one of these is going to be like,
top of my head.
these are going to go away or something, right? That's what's going to happen?
Well, so I was just looking at the original equation. You have, right, that 2t, and with the periodic nature of sine, I was thinking, right,
Yeah.
like at the either like pi over 2, I'm thinking it's 3 pi over 2. The 2's would cancel out and you would get like 3 pi minus pi sine of t, and sine of t at 3 pi is -1, so you'd get like 4 pi. So maybe pi over 2 you would get pi minus pi, so y would equal 0.
Yeah. Okay. Yeah, so we could say, okay, this is like a lucky guess. You could like guess T1 is equal to pi over 2, and T2 is equal to negative pi over 2. Because again, we can't have 3 pi over 2 because it's got to be between negative pi and pi, right? The reason, Tuma, why I'm guessing that is, first of all, I know that cosine of pi over 2 is the same thing as cosine of negative pi over 2, right? You see how this is like all the way up, this is all the way down? And cosine for both of those is going to be 0?
Yeah.
Okay. And then here's the other cool thing, is that sine of t1, so sine of pi over 2, that's going to be equal to 1. And then sine of negative pi over 2 is going to be equal to -1, right? Okay, so then let's plug it in. Let's see what happens, right? So if I plug in pi over 2, I get 2 pi over 2 minus pi times 1. And let's see if that equals 2 times negative pi over 2. And then that's going to be plus pi times 1. Or because it's pi times -1, right? You see that? You think?
I don't like this problem at all.
Yeah. Again, this is true, right? I need the cosine of my two t values to be the same. So I need things to be, they need to be a mirror of each other across the x-axis, right? So I need either like this and this, right?
Okay.
Or I need this and this in terms of my t1 and t2s. Because the cosine of those will be the same.
Oh, right.
Does that make sense? Right? And then what I'm doing is I'm saying, okay, but well, one of the other really fun reflections over the x-axis is this, right? When it's pi over 2 and negative pi over 2. Cosine of both of those is the same. It's 0. And then the fun thing I notice is that, oh, the sine of this one is exactly the negative of this one, right? And it's also 1, which is nice. So that's why I picked it.
Oh, I can't think of that on top of my head.
No, but maybe you want to, if you had done your table, that would have been fine as well. But the issue with your table, Tuma, is that you can only go from negative pi to pi. So you can't go to 3 pi over 2, 2 pi over 2. You have to go to the negatives.
Oh, I see.
Do you see that? Because, okay, when you solve this, right? So when I... What's up?
How would like my
Your table look?
Like,
Yeah, okay. So if this is t, right? And then this is x, and then y, right? This would go from negative pi, right? I would even say like, yeah, negative pi over 2, 0, pi over 2, and then pi. Right? That kind of makes sense. But you have to pick two. But you have to pick two different t values, right? So in this case, we're picking this. This is t1, and then this is t2. Because that's the only thing that makes sense for the first thing here, where the cosines have to be the same. Because if I look here, right, negative pi is like over here, pi is here. I guess you could have chosen this, right? These would work as well.
Wait, so negative pi is from...
You can't do pi. They said it's strictly less than pi, but it can be equal to negative pi.
Sorry, we can't do pi. Okay, so we can't actually hit this one. I bet.
Like just the top, like that would be the top stuff, like on top of the... If I could point at it.
What do you mean?
Like
this?
The top side of the unit circle?
Yes. This would go from 0 to pi. This is 0 to pi. And then going clockwise, like the opposite direction, that's going from 0 to negative pi.
Oh, I see.
Right?
Oh. So
But, okay.
pi to pi.
Yeah. Okay, so from here, I think this makes sense, because this is pi minus pi. That's equal to 0. And then this is negative pi plus pi, which is also equal to 0. So we figured it out, right? So t1 equals pi over 2. t2 is equal to negative pi over 2. These are the two different time points, okay? And then to find the equation of the tangent lines, I think you need... okay, so the equation of a tangent line is the slope. Oh, I know how this works. Okay. So slope of a tangent line is equal to what?
Y equals mx plus b.
Yeah, y equals mx plus b. I mean, that is true. Y equals mx plus b. But this is the slope, right? M is the slope.
Oh yeah. It's m.
What's another thing in calculus to say what the slope is?
My name is Jeff.
Jeff has it. Yeah.
Second derivative.
No, it's the first derivative. It's the first derivative. Slope of a tangent line is dy over dx. Another way to write dy over dx is to say this is the same thing as dy dt divided by dx dt. Okay?
Oh, right, yeah. I've seen
Okay.
that before, but yeah.
Yeah, because, right, the dt's cancel. Because they're just a fraction. Anyways, so you can figure out what dy dt is, right? That's right here. Okay, so dy dt is 2 minus pi cosine of t. Sensation, what do you got? You got something funny for me? And then dx dt is just going to be pi sine of t. Does that make
I've
sense?
just copied and pasted this. God, that's fucking horrible.
Top tip: if you put an extra strong mint in the plug hole of a sink, you will get a fresh minty smell when you piss it. What?
Why has somebody written that?
I don't know. That's Reddit, dude. Okay. Does this make sense, Tuma? How we got to here? Are we lost in the sauce or what?
Yeah, it's just the derivatives.
Yeah, good. It's just the derivatives. Okay, cool. Awesome. All right, good. What's up, Greeny Eyes?
Oh, yeah.
Okay, so now we have the slope, right? But the slope depends on t, right? So let's figure out what
Should
dy
be
dt.
multiplied, right?
Wait, what?
No, it should be multiplied by pi sine of t, right?
No. It's dy. It's dy dt divided by dy dx. No.
dy
dt divided by dx dt. No.
I don't know if that's because technically, like it works out like a fraction, but
Yeah,
by the
it's a
chain
fraction.
rule, right? It would be dy dt dt dx.
Right. So you're multiplying by 1 over dx dt.
Well, dtx isn't necessarily 1 over it.
Oh man, don't ruin my birthday, dude. What?
Emotional, damn it!
I think you can just do this. Someone in the math gods, am I okay for doing this? Can I just fucking write? I'm pretty sure I can.
I've seen that before and it works.
Okay, we're gonna assume it works. Raven says I'm fine. Jeff says it's fine. Okay, I appreciate the apprehension. I understand why I would get nervous about it for sure. But yeah, we're gonna roll with it for now. Okay, it's a form of the chain rule apparently. Okay, cool. All right, so at T1, right? T1 was equal to pi over 2. So let's evaluate that, right? So that's 2 minus pi cosine of pi over 2 over pi sine of pi over 2. Well, cosine of pi over 2 is 0. Okay, and sine of pi over 2 is equal to 1. So you just get 2 over pi. Okay, and now I'm going to go evaluate it at my second time point, which was negative pi over 2. I mean, technically it's the first point. Yeah. So, this is still 0, right? So this is 2 minus pi cosine of negative pi over 2. This is still 0. But then this becomes pi times negative 1, right? This is going to become negative 1. So now you get negative 2 over pi.
Yeah.
Okay. Machka says, you can treat first derivatives as fractions if you know what you're doing. I never know what I'm doing.
Emotional, damn it!
Second derivatives behave more like dy, dx, dx. Yeah, I get it. It's like an operator. Yeah, I get that part, yeah. Okay. All right, so here are our two slopes, right? So all we got to do now, right, is plug it into our equation here. We need a point, right? So we have to figure out the point of the intersection, right?
Right.
Okay, so point of intersection should be the same, right, for each T1. Doesn't matter which one you use. It's just because it's hitting itself, right? So the point of intersection, that's x is equal to 2 minus pi cosine pi over 2. Which that's just equal to 2. And then y is equal to 2 times pi over 2 minus pi sine of pi over 2, which that's is equal to 0. Sine of pi over 2 is equal to 1. 2 over 2 is 1. Pi minus pi is 0. Okay? So that's 2 comma 0 is our intersection point. Yeah?
So that's my answer.
Well, okay, so that's the intersection point. This is the slope. So we're going to say
yeah,
tangent line. Tangent line. I'm just going to put this in point slope form, right? So I'm going to say y minus y1 is equal to mx minus x1.
Yeah.
You can rewrite it mx plus b if you want to. So that's going to be y minus 0 is equal to 2 over pi
Like
x minus 2. Right?
Yeah.
Okay. And then y minus 0 is equal to negative 2 over pi x minus 2. And there you go.
Yeah, I looked it up. It is legal as long as it's locally invertible.
Love it. Okay, cool.
So if you can't invert the function, then you can't do it. But in this case, it works fine.
So as long as I'm not dividing by 0, I guess. Yeah, right. Yeah. Invertible
In
means
essence, yeah. So like
Gotcha.
at what's it called? Pi, 0, pi, 2 pi. In this case, it wouldn't work.
Yeah. Yeah,
Those
I see.
values would be-
Because, yeah, inverting would be 1 over 0. 0 over 1 is not the same as 1 over 1 over 0. Well, I guess it's kind of close, but it's not really.
I'm so brain dead right now. I don't struggle with like the last bits that you did, but like finding the first part
Yeah.
was like, it was kind of annoying.
Yeah, no, I agree. So, again, my general strat for what I would do here, Toombs, is I would do this. Set 2 different T1s and T2s, write them out, and then come up with like some simpler expressions, okay?
Right.
Do you make sense? So, right, this was my expression for x, right?
Yeah, just simplify it, kind of.
Simplify it. This, I don't know if this is like easy to solve based on knowing that, like, the issue here is that, like, T1 and T2 live inside trig functions, but they also live outside the trig function. So it becomes hard to isolate that. Yeah. This one is really just what I call like a gut feeling intuition. You have to just kind of like check the different values and like think like what would maybe make sense. Like cute tricks usually happen at pi over 2 or pi or even like pi over 4. Those are when like
just like
sorry, what?
reverse engineering it. So like what made me be like, oh, I think it would work at like pi over 2. Because I was like, okay, it's periodic on intervals of pi, but I was like, it seems really convenient that they would go 2 pi so that a 2 would cancel and then multiply by pi. So when it's equivalent to 1, you're just adding or subtracting pi's.
Right. So
I didn't like
Breskel saw this too,
look at it.
Breskel saw that like there's a 2t. So wouldn't it be nice if this was pi over 2? Because then you would just get pi, right? And then this is also just a pi. So I just need this to like go to 1. And so, right? Because if I tried pi over 3, for instance, that wouldn't really work, right? Because now I have like 2 pi over 3. Sine is never going to give me 2/3 with anything that we know, right? Sine only really gets you like 1/2 or like square root of 2 over 2 or like square root of 3 over 2. Those are the only other values you get, and you can't put a value into sine that'll get that, but that'll also pop that out here as well. I guess that's kind of what I'm trying to say.
The point was like, think of it, if you were actually like, you were the one writing the problem, you'd be like, okay, well, if I was giving this question to anyone other than Dr. Gold, I'd make this relatively easy to do and make sure that things work out cleanly and nicely. And it can be very helpful sometimes in classes to be able to look and be like,
think like the test designer.
If I was designing this problem and I was reverse engineering this would make it very convenient if these things happened, and a lot of the time they do.
Yeah, because if they didn't, like, the world is a lie. Because again, I don't really know if you could like get like an analytic thing for this. I guess you could move this over. You could move this over, so you get 2 t1 minus t2 is equal to pi, and then we'd say like sine t1 minus sine t2, right?
Yeah.
Right. And then I think maybe at this point you start seeing that like, oh, wouldn't it be nice if I don't know, somehow this became like 1? Because then I could make this like also equal to like 2 or something.
Look, can I see the original part, like the cosine equal cosine one?
Yeah.
So after you simplified that, what did you do after that? I forgot.
Oh, okay. So after this just told me that when picking a T1 and a T2, they needed to be reflections of each other over the x-axis. So because when you're doing your table, you have to pick 2 things, right? I have to pick two values, right? If this is t and x and y, I need to pick 2 different values of t that cause whatever my thing. I know technically you can't have pi, whatever, like something like this, right? I need to pick 2 different values of t that get me the same x and y. You're having to guess like too many things, right? I need to guess what is their point of intersection, and then I need to somehow figure out what are the 2 t values that get there. So if you know where the intersection is, then it's easy to figure out the t1 and t2, but we don't know the intersection. So you're kind of like figuring out both at the same time. But this tells you at least that your t1 and your t2 need to be reflections, because that's the only way cosine equals cosine.
That one makes more sense, but the other one was a little unclear.
Yeah, okay. So, so what this tells you is that, okay, so, right, they have to be reflections, But the issue is that like they could be anything, right? It could be this and this. It could be like this and this, right? So that's where the intuition has to kind of come from. Of okay, well, let's pick some pairs of like nice t values that are reflections, and let's see what happens when I plug them in. I think maybe it's easier to see here, right? Because if this is pi over 2 and this is negative pi over 2, it's like minus minus. So then this just becomes pi. And then here, sine of t1, this is pi, sine of pi over 2 is also 1. Sine of negative pi over 2 is minus 1, minus minus 1. So then you get the same thing. You get 2 pi. Here you would get 2 pi, I guess, or something. Oh, sorry. Yeah.
So you just want things to cancel out or something? I don't know.
Yeah,
It's
right.
so
Pi over
weird.
2.
I don't like this.
Yeah. You don't like the way I write pi?
No, I don't like the.
No.
like
Not
this
Raven says they
problem.
don't. Not Raven doesn't like the way I write pi.
Oh.
Okay.
You write
yeah.
some of your symbols a bit funky.
I do. Okay. Well, let me think here. This
I
is
would do
actually
some sort of
we could do a difference to product. I can do
periodic
I can do a difference to product rule here. Can I not?
You could. I was just thinking basically just making.
No, we're gonna bring out the big
on
guns. Bring out the big guns to do this one, dude. I'm pretty sure I can do it. I'm pretty sure I can fucking do it this way. Watch this. You just realized I'm wearing a wife beater? No, dude. Is it an Italian tuxedo?
You done messed up,
I'm just saying, dog. It's not a wife beater. Okay. No. Oh, sorry. I need a difference of signs. Sorry. Let me do this one because I think actually something cool does come out of this. Okay. Wait till you see his alphas. Yeah, my alphas are fucking disgusting. We're not gonna do that. Okay. All right. So if I wanted to convert this into this, so watch. This becomes pi, and then this is sine of t1 minus t2 over 2, cosine of t1 plus t2 all over 2. Yes. Okay. Now here's the cool part. Here's the really cool part here. Okay. This is t1 minus t2. Okay. Because cosine of t1 has to equal cosine of t2, right?
Yeah.
We agree from this, right?
So there a 2 out front?
Where? Oh, with this.
speaking.
Yeah. Sorry. Yeah. Yeah. You're right. Sorry. There's another. Sorry. I always forget that too. Okay. So because of this, because cosine of t1 needs to equal cosine of t2, right? A nice solution would be, cosine of t1 equals cosine of t1. Duh, right?
Yeah.
But here's another thing you learn about cosine. Cosine of negative x is also the same thing as cosine of x.
Oh, what?
You didn't know this? So cosine of like negative 3 is the same thing as cosine of positive 3. This is the definition of cosine being...
Don't matter.
The signs don't matter, exactly. So when you got to this, right? Cosine of t1 equals cosine of t2. Even if you don't know shit about the unit circle or like graphing it, you should be able to see that, this just means t1 equals negative t2.
Oh.
Or like t2 equals negative t1, right? Because if this is negative t1, it turns back to t1. It's the same shit.
Yeah.
Okay. So this is cool because now here, right, if t1 and t2 are opposites of each other, this whole term goes away.
Oh, what?
Right? Because now t1 plus t2 is 0. And cosine of 0 is just 1. Okay?
Yeah.
Again, this is overkill. The easy way is to just look at it and figure it out. But if, again, let's say you were Helen Keller and you're blind, you don't know how, you can't see shit. Like, you can do it with just the math, I'm pretty sure. So,
Right.
Okay, now
doesn't apply to sine though.
it doesn't apply to sine. So watch this. Well, no, so t1 equals negative t2. So watch what happens here. So I get t1 minus t1, right, is equal to pi. And then this is sine of t1 minus t1 over 2, right? So then I get 2t1 is equal to pi sine of just sine of t1. Okay? Because this is a 2t1 over 2. And that just becomes t1. Okay, is it obvious here yet? Sine of what is equal to what? Not the 2 is a z. No, my z's have lines through them.
Emotional, damn
Don't
it.
go and do that. Please.
You do it.
Is that a chip sandwich? Is it a fry sandwich? It's a chips crisp sandwich. Okay. Again, this is a little tricky because I have the variable outside and inside the trig function.
So yeah, for the uninitiated, the joke in that picture is the name of that changes every 5 miles.
Oh, in England, yeah.
Yeah.
Okay, one sec. 2 over pi is equal to sine of t1 over t1. I don't know. The sign of this is as t1 goes to 0, this equals 1. I don't know. Okay, I don't know. I think it. I don't know analytically at this point how you can separate these two, besides like putting it into like Euler form, which I don't. think
Yeah, I was
we
gonna
can do.
say using like
You
the complex definition of it.
Yeah.
Or
I don't know, man. This is so weird.
I think at this point you just say t1 equals pi over 2, because when you plug that in, right? Look, so this is 2 pi over 2. That's just equal to pi, and then this is right. Sine of pi over 2 is equal to 1.
I think I have math.
So it's just equal to pi.
GD.
No, it's not. Again, this is a shit question, honestly. I mean, it's not a shit question, but it's shitty in that there's no mechanical way to do this. You have to draw upon like your intuition and like holistic knowledge of math to get it.
I
Yeah.
think that's where my problem was, because I couldn't picture it like visually.
Yeah.
what
I
looked
can't-
like a vertical sine wave with a bunch of tiny sine waves inside of it. If I'm thinking of it correctly, because you're actually just oscillate between 1 and 2. Or sorry, not 1 and 2.
Yeah. Okay.
Yeah,
Anyways,
you're
you-
actually just oscillating.
you'd get enough
Go
partial
up.
credit. I'd at least like I do this, and even if you're lost, as long as you have that, you should get half points at least, right, for doing the correct thing. Figuring it out, that's kind of like that's a jump, which again, you will get if you do enough of these questions. Now you will think, oh, if I see something where my variable is outside and inside the trig function, then maybe I need to try to use like pi over 4, pi over 2, or pi or something. Yeah?
I don't know. I'll probably talk to my professor. He probably knows something I don't.
Yeah, well, yeah, I mean, yeah, show him this. I mean, go over this so that you know what you're doing, but like, ask him if there's like an analytic way to solve this versus just like some magic guessing. Okay, cool. All right, great question. I like it. It's fun. Good job. Too nice. Yeah.
I'm going
Go play some soccer.
soccer. They actually told me that they wanted to play soccer today, but one of them didn't. They didn't want to show up.
Wow. That's why you left last time. You're like, oh, I have to go play soccer. Go play soccer.
Now I have to do leg day.
All right, go do leg day. I did chess yesterday.
Over math.
I did
Soccer.
chess yesterday too.
Nice, dude. We're gym bros. I mean, also like, well, no, usually chess day is Monday, right?
It's for me. It's Monday and Wednesday because I hit it twice a week.
Oh, you do 3-day splits?
I hit every muscle twice a week except for legs. I only hit it once.
At least you hit it, dude. Some people just never, like me included, just like never do leg day. No. Yeah, I'm the worst.
Yeah, it
Okay.
helps me.
Good. I'm glad. Yeah. Oh, right. You're bodybuilding. That's right. I forgot about that. Yeah.
Just for fun, yeah. Or yeah, mostly I'm working out just to like feel like.
It's fun to hit PRs, right? That's what I did last year for like 6 months. I was with my friend his dad was like Mr. whatever Olympiad or something, or his grandfather, and I got my bench up from like 235 to 315, and I was like, yeah. I was like, it's super dope. I was like, oh wow, I can do it. And after that, I was like, okay, now I'm done. Because
dude, I can only bench like 225. That's it.
you're fine, dude. You're young, dude. I could only do 225 at your age is insane. It's already like really impressive. Don't believe all the weird like TikTok people thinking that like 225 is like
Yeah,
normal.
they raised the standards.
I know they raised the bar literally.
You done messed up, Aaron!
Okay, all right, let's
I
go
think you
roll.
could solve it with triangles. I'm gonna give it a shot, friend.
Let's go gambling!
I think that was calculus, Lucky Cat. Let's see. What we got next? Machka, it's you. Congrats, Machka. Oh man, what do you got me for? Oh, volume of solids. Actually, I like these. These are usually fun. This is calc. What's up, Crazy Run? All right, here we go. Find the volume of the solid whose base lies in the region bounded by that, where each cross section perpendicular to the y-axis is a square. Cool. This is like calc 2. Good solid math here.
My name is Jeff.
Jeff, you are right. Sensations. Wait, goodbye? What's the goodbye?
What?
I don't know. I'm trying to see what blue means. Oh, blue saying. Oh, okay, never mind. Yeah. Okay, there you go. All right, here we go. All right, so let's like try to graph what this looks like. So x squared minus 7 over 40. I don't know. It's. I mean, I guess it's something kind of like this. Wait. If this is y, this is x, and this is z. It's gonna look something kind of like this, I guess, right? It's a U. It's a U in the XY plane that is shifted down on Y. Okay, but then we're bounded. We're bounded by some things here. Okay, so we're bounded by x equals 0. Sorry, this is x equals 0, right? We're also bounded by... Sorry, no, this is x equals 0. What am I saying? Okay. This is x equals 0. We're bounded by y equals 1 and y equals 2. Cool. It's like this. So this is y equals 1. And then we're also bounded here by y equals 2. Okay, here's a cool thing. And that's the base. Okay, so the base is here, right? And it's bounded by this thing and this thing and this thing and this thing. Right. Okay, yeah. Well, I like drawing the 3D-ness of it. I think the 3D-ness of it is really cool. Okay, so then the cross-section is perpendicular to the y-axis is a square. So this is really fun. So what we're going to do is we're going to add up a bunch of slices as we go down y. But as we go there, every slice we add has to be a square, where the base of that square is going to be from the y-axis to, we would say, like the x value, right, of this function. And then the height is also going to be the same. So these are like the shapes we get to build. Right? So here I'll draw one over here. This is like the front one we're going to build. And then this is the back one. It's like the back square. I'm getting better at my 3D skills. I think it's quite fun, actually. Okay, cool. So, how I like to write these is first I want to determine like what direction we're going. So since we're adding up my bread slices along y, I know this is going to be a dy integral. And then I know in terms of y, I'm going from where y equals 1 to where y equals 2, right? That's my starting y, that's my finishing y, as we start adding all the slices of bread. And then, so this is going to be this. And then what we need to do is we need to figure out what the area is as a function of y. So the area of this thing needs to be a function of y because my integrandy thingy, or my differential, is in terms of y. It's in terms of dy. So this is where, yeah, Jeff brings up a good point. Let's draw what it looks like just in the xy plane. So that's going to look something like this, right? And then we're going to do it from y equals 1 to y equals 2. So as we're traveling along dy, the area of our shape is just going to be equal to the side squared, right? And the side is going to be equal to this distance, right? So from here to here, this is the side. That's S, right? Because the area of a square is just side squared, and one of the sides has to be this distance. Okay, so then I need to know what this distance is in terms of y. Okay, so that's what I'm asking myself. I'm like, okay, cool. Well, like, what is this in terms of y? The way to get that is to look at this. So we're going to say, okay, well, y equals x squared minus 7 over 40. Let's rearrange. So I'm going to get that 40y is equal to x squared minus 7. So 40y minus x squared is equal to minus y. Okay, so then let's rewrite it. Let's move around. I'm going to say y is equal to x squared. Sorry. Wait. What am I doing? Sorry. My 7s look like y's. Oh no. Oh no, I made my own mistake. Sorry. I'm like, wait, what am I solving for? Okay, sorry. 40y equals x squared minus 7. There we go. 40y plus 7 is equal to x squared. Take the square root of both sides. And we're going to use the positive one, right? Because I want positive values of y. Technically, this graph like goes over here, and there are negative values of y. But we don't care about those. So I'm going to say x is equal to 40y plus 7 all to the 1/2. And this is equal to side. That's equal to s. Okay. So then s squared is equal to 40y plus 7. Okay. Does that make sense, Machka, so far? Okay, great. Okay, cool. So then, I'm going to do my integral. So now this is integral from 1 to 2. A is s squared. S squared was 40y plus 7. So I'm going to say, okay, 40y plus 7. And then this is dy. And now this is a very simple integral to do. So this is just going to be 20y squared plus 7y, evaluated from 1 to 2. So I'm going to get 80 plus 14. So I'm going to get 94 minus 27. And that's going to be equal to 60. Oh, 6, 7. God damn it! You got me again?
Oh, no.
No, you did not.
No.
No, you didn't, Machka.
What the fuck is this piece of shit?
Oh no!
Oh man, Machka. I should have known, Machka. You got me last time with a 6-7 joke. This one is good, yeah. This one is very well hidden. It's very well hidden. But to be honest, I was also like starting to question because I'm like, this is whack.
Oh my god, bro.
Like, this is a very whack function to have a base for. Damn, how do people reverse engineer these? How do you reverse engineer this? Oh. Okay. Thanks for playing. It's well played. It's very well played, Machka. I saw it, dude. I saw it happening in real time. I was like, 94 minus 27. Oh no. I'm about to get got, dude. Sorry, I hit enter early. You're okay. That's a good question, though, Machka. Take any general problem and tweak the parameters. Yeah. It was just interesting. I mean, I guess I can see it, right? if you know your boundary is from 1 to 2, then you just set this to, you know, get the squared thing or something. I can see how you do it. That's super fun though. You know what I should do? I should do like a video series where we just do math questions and every time the answer is always 6, 7. I think that'd be a fun little like meme type shit, right? For like for TikTok, right?
Yeah, I'd probably get some views on
Probably get some
TikTok.
views. Yeah, right? I'd be like, hey, here, we're going to show you how to solve this problem. And then, like, I teach, right? I'm, like, you know, showing, oh, this is how you do, you know, solids of whatever stuff. And then I'm like, and then the answer is always 6, 7. Won't finish that. You can guess what I was trying to type. Dipshit? You're trying to say dipshit to me?
Oh my.
All right, whatever. All right, let's go. Let's go see someone else's question. Wow, the queue has gotten quite large. Unlucky dog.
I think some of these are like spam again. Like
Well, so
Wizard of
interesting.
Oz is a
Yeah.
is literally asking, write a short essay of 3 to 4 pages, 900 to 1200 words on one of the following topics, and it's for classics of Western philosophy.
Well, you know what's interesting? So unlucky dog, right? Who posted this question? Also posted this question, right? These ones are also ridiculous. You can see that their votes are nerfed because they only get plus 60 between the two of them. So I took what you said, Breasticles, right?
Oh, yeah, I see.
Right. So if someone submits 2 questions, it splits the vote rate.
Yeah, that makes sense.
So I mean, yeah, very cool. We're doing some cool stuff here. So Lucky Cat is at 300. You've hit the maximum rate, 360, because you've been waiting more than 2 hours. So you've hit the maximum rate of questions. I'm slowly making this thing like fair. Anyways, let's go choose one.
Let's go gambling!
What are we gonna get? DM's Grader. Lucky Cat says I'm calling it in next
Cat's
time.
not lucky today.
Yeah, not lucky today. Breasticles was the luckiest, dude. Breasticles got first. Geography.
Yeah, that was like my sign to teach Dr. Gold PDEs.
Yeah, he was like, "Yo, I got my chance. I'm here. I got it." He's like, yes. Okay. DMs, which one do you need help with? I mean, you kind of did all of them.
There's another 6, 7 in this one as well.
Is there another 6, 7? Oh, there is here.
There are
Calculate the
2
length
of
of
them, actually.
JM. Do number 5? Well, okay. All right, we'll do number 5 then. Okay, fine. Yeah, Blue's like, yes, do 5. Okay, here we go. Luca is planning a bike trip around France. The polygon drawn on the map represents Luca's estimated route. The vertex of each is labeled with a letter. What distance will Luca bike from A to B? Cool. Yeah, I mean, this is all Pythagorean stuff. You're just doing... So, here, I'm going to do like a little side tangent here. Because all of this is just using the distance formula. So, distance formula, right, says that the square root of x1 minus x2 squared plus y1 minus y2 squared is equal to the distance from x1 y1 to x2 y2. Yeah, this is just distance. We can then extend this actually into more dimensions. I could say that, right? If you start doing things in like 3D, this becomes z1 minus z2 squared. You're calling it? Lucky Cat says I'm calling it. I'm calling it in. This would be 3 dimensions. So let's explain like where this comes from. Yeah, Lucky Cat says me first. Okay, Lucky Cat, you are first. You're next. Lucky Cat says I'm not leaving the chance anymore. Okay. Let's say, for instance, right? You had a point here that was at x1 comma y1, and you have another point, let's say like out here, which is at x2 comma y2. And I want to figure out how far does it take, how far is it to go from here to here? And this is something we end up doing in kind of like multivariable calculus too, when we start doing like Jacobians for like coordinate transforms. What you're doing is you need to find a coordinate system that is perpendicular to itself. And conveniently, the Cartesian XY coordinate system is perpendicular to itself. So when we go diagonally, we can decompose this into going only horizontally and also going only vertically. And then this will always make a right triangle. This is like one of the really cool things. So if you don't want to memorize this formula, which I wrote down wrong. Sorry, this should be squared. You can also think of it just in terms of right triangles. Because, again, let's call this the distance d. We could then call this, right, the amount it has to travel in x, right? This is the same thing as going from x1 all the way to x2. So this distance is equal to technically x2 minus x1, which will show when you square it is basically the same thing. And then this distance, we'll say from like y1 to y2. This is equal to y2 minus y1. And then if you do the Pythagorean theorem, right, which says this squared plus this squared equals this squared, we could say x2 minus x1 squared plus y2 minus y1 squared has to be equal to d squared.
Good job.
And then all that's left to do is just square root both sides. And then you can also notice, because these are squared, it doesn't matter if you do like x2 minus x1 or x1 minus x2. But you'll end up getting that. You get the same thing. x1 minus x2 squared plus y1 minus y2 squared is equal to d.
Oh, yeah.
So all you have to do once you have that is just plug that into here. And that's kind of like just busy work. Like, who cares? I assume you already know how to do that. You said there's another part. Okay. Well, maybe like, let me look at like one of the other parts. Because that's cool. It's distance equation's fun. But wait, wouldn't we that assume the Earth is flat? Bruh. Is flat on the, you know, honestly, not flat on the scale of like traveling across France. I agree. I agree. It wouldn't be correct there.
Yeah, I believe we gotta bring in some differential geometry here.
Yeah, or what's it called? The matter something. There's a name for it. There's a name for the formula.
I forget the formula, but yeah, basically just it's like all differential geometry to figure it out.
Okay, so wait, what the hell is this question, dude? What? Student A answer, student B answer, student C answer. What? Oh, I see. Dude, this is like one of these where like the math worksheet is like a game. It connects. Oh, these are always fun. Yeah, it's to like we used to do the ones where it would spell out a word or something. You guys ever do those? Or like the numbers. You guys ever seen this? Like here, math worksheet spell out word thing. Yeah, something like this. These are always like so fun. Like you would do these, and then based on the number you got, you would put the letter, and it would say something like, "Ooh, the hidden word," and it's like triangle.
Disqualified.
Yeah. This is where like, so for instance, like this is 58. So then down here, where's 58? Well, this is a badly done project then, because I don't see 58. Or 97, whatever. That's probably 97. You would put like an R there. Yeah, anyways, that's how that works. Okay, so fewer letters than sums. Oh, I see. Oh, that could be right too. Write your answers below. Student A answer, student B answer, student C answer. Find the perimeter of triangle AEB. Where is AEB here? Oh, okay. So wait, you have to do all... Dude, this is so, like, exhausting. You have to figure out all of this. Then you got to find the perimeter of this. Kind of blows. Okay, sure. And then find the area of triangle ABC. So then you got to go find the area of this triangle, which is 1/2 12 times 8. So 48. Is that what you got? Yeah, cool. Oh, and then you add these all up, and you make sure that you got 100.6. Yeah, I'm exhausted just looking at this, honestly.
Not good.
This is annoying, dude. What? Really? This is your homework? This would just take forever. That's why I'm passing it off for you to do.
Oh no.
I don't really want... I don't want to do your homework. You know how to do it. No, please do it. I'm sorry, Blue. I do have a PhD, yes. But I can help. Here's what I always tell the students. I will never like do your homework for you. I'll help you learn how to do your homework so you can do your homework yourself. But in terms of like me doing it, like
oh no.
I don't know. There's better uses of my time. Like even if you were paying me to do this, I still wouldn't want to do it because it's just so monotonous. Yeah. What's the Kimura Sensei? My wife, what's this?
Nanda? 女の人の写真。綺麗な人やな。誰?
My wife.
Oh, my wife. That's funny. My wife. Okay. All right. Bonus: if you finish early, find the perimeter of the whole polygon. Yeah. This is actually kind of a fun one. I remember doing this, right? This is one you can do. Ain't no one doing the bonus. This is always a fun one. So if you want to, for instance, here, if you want to find the area of this, what you do is you find the area of the whole like square or rectangle that encompasses it, and then you subtract these areas. Have you ever done that? Yeah, I will do that one for you. I will help you with this. That's the one thing I'll do. Because yeah, this is actually kind of a cool trick. Right, because finding the area of this would kind of suck. You have to find like the distance of this, which is a diagonal, and then you have to find the height of this, which is a diagonal, and then do 1/2 base times height. But an easier method is to notice that, yeah, right, this is a 4 and 4. This is an 8 and an 8. This is also 4 and 4. Okay. So the whole thing, the whole square that encompasses it is an 8 by 8. So here we could say like area is equal to 64. And then all I'm going to do is I'm going to subtract the areas of these three triangles. So this is going to be minus the area of this triangle, which is 1/2 4 times 8, right? Base 4, height 8. This is 1/2 4 by 4. That's this one. And then this is another 4 by 8. Okay. So, what's that? 32 and 8, so minus 40. So 64 minus 40 is equal to 24.
Oh, yeah.
Okay. Right. Okay, so there you go. So here, I helped you with this one. So the area of the triangle there is 24. Or I think, yeah, 24.
Oh, yeah.
Cool. Yeah, if you have all the other stuff, you can figure it out. Okay, nice. Great. Okay, yeah, go do your homework. Go do your homework.
Well done. Well done.
I agree, it sucks. That's honestly, that to me is like just like busy work, man. That's just a lot of busy work. Dr. Gold, let's try to spin one more time. Okay. But what if it lands on somebody else? What happens?
I will sit here and genuinely guffaw.
You'll genuinely laugh. All right. Okay. Just testing. Well, yeah. One sec. Where is it? I mean, you do have a 43.7% chance. We can try it. You might regret it though.
Let's go gambling!
I don't know. I mean, it is independent technically.
You're not that guy, Falco. You're not that guy.
Technically, it's M, dude. M. Technically, M. There's no way. It's okay. I can do this one real quick, and then Lucky Cat, I'll do yours because you did choose me first. Just because if I don't do this one, it'll screw up the whole like algorithm. I have to do it if I select it. Okay, here we go. All right, the momentum of an electron is changed by p. Then the de Broglie wavelength associated with it changes by 0.5%. The initial momentum of the electron will be. Okay, so de Broglie wavelength. We did this before, right? What was it? I remember like E is equal to HC, which is equal to HF over lambda, I think. No. E equals HC. No. E equals HF. That's what I wanted to say. Which is then equal to HC over lambda. Okay, yeah, cool. That's for a particle. I know P equals MV, but how does that relate with de Broglie wavelength again? Oh, I think I remember. Wait. P squared over 2M is equal to E, right? And I think that's also equal to HC over lambda. So P equals H over lambda. Okay. P equals H over lambda. Okay. If the momentum is changed by P, then the de Broglie wavelength... Oh, okay. Okay, so... We're saying lambda changes by 0.5%. What do you mean? Does it increase by 0.5%? Or does it decrease by 0.5%? A little curious there. So, does lambda become 1.005 lambda? Okay. Right? Okay. So, we could say lambda 1 is just equal to lambda. Lambda 2 is equal to 1.005 lambda, right? And then we want to figure out the initial momentum. Okay, so we're going to say that P1 is equal to X, and then that P2 is equal to X plus P, right? Because we said the momentum is changed by P. Is it adding? I think it's adding, right? Must be adding, yeah? Okay. Okay, so then writing this, right? So P1 is equal to H over lambda 1. P2 is equal to H over lambda 2. You can divide the two by each other. You get P1 over P2 is equal to lambda 2 over lambda 1. Femva. Ooh, I like that sticker. That's really cool. Nice sticker, Fem. I need that sticker. Where'd you get this one from? Erome Femvox fan. Oh, I'm gonna subscribe to them. Yeah, nice, cool. Erome Kim. Okay. So then let's plug things in. So X over made them your teachers and monsters should be arrested for war crimes. Oh no. And then this is 1.005 lambda over lambda. Can you use it until you ban me? No, I'm never gonna ban you, Fembox. Fembox, what? You're the solutions manual, Fembox. Bless you.
I'm gonna tell Fembox that when I start streaming.
Oh, please do.
Start the stream. No, what I was gonna say is I'm gonna start the stream and then I'm gonna make him like think it's gonna be fine, and then I'm just gonna ban him so that he can't watch my stream.
Oh man. Okay, so x minus 1.005x, that's equal to negative 0.005x, is equal to 1.005p. This is the same as negative 1 over 200, right? Is that over 200? Yeah. Okay. Yeah, okay. Cool. All right, so what? P equals negative 1 over 100? Negative 1 over 200? I don't know, because this is basically 1. Like, who cares? Okay. Which is none of these answers. I don't like the changes by 0.5%. Okay. Let's send it at chat. Maybe chat also like knows how to. Just move the decimal over 3 places on each side for here. Oh, for this side. Oh, I see what you're saying. You're saying I could just do this. 1, 2, 3. Right. 1, 2, 3. 1, 2, 3. Oh, I see. Okay. 5x equals 1005p. Cool. Okay, x equals 200p. 201p. Oh, I see. Thank you, Fem. Sorry, that's much easier. I was tweaking for a second. Okay, answer's 4. Right? I think so. Let's see. Let's see what chat said. Yeah, 200p. Cool. Nice. Good question. All right, cool. We got it. That's kind of weird, but it's fun little algebra. Good job. I'm assuming that's Max. Okay, let's do Lucky Cat's question next. I'm not gonna make you spin again, Lucky Cat. You have to be close to number 1 at this point, right? What's up, Edvin? Dang it.
Oh, dang it.
Okay. I'm close, but there's 10 minutes left. Where you're close? Well, it is random, so you could be solved next. Maybe I'll extend some time. Let me see. I'm feeling okay today. Day 1 on breath, day 1 ban on. Okay, describe in words the following transformations.
I wouldn't actually ban you.
Yeah, he wouldn't actually ban you.
There's a very small group of 4 people that are really interested in watching my streams and would watch it all the way through. I would basically be cutting my viewership by like 25%. $10 would be a problem.
Oh, trigonometry boy? Okay. Here, okay, so this moves it. Well, yeah, Trig, you've been waiting for a while, Trig boy. Oh, yeah, you're close. Okay. Maybe, yeah. Here, just stick around. I'll probably do yours, honestly. Okay, we're moving to the right one. This is stretching horizontally by 4. And then this thing's doing something. So this is vertical flip and stretch by 2. And then the final thing is to go up by 3. Yeah. I would say just up 3. Right. Vertical flip is technically not the correct term. Yeah, we should say like reflect over the x-axis. Yeah. Okay, cool. Yeah, that's all they are. By hand, sketch the graph of g of x and f of x. You include a table of values to communicate. You may check with graphing technology. Well, okay. I mean, I assume you just put this in, know how to graph it, and then, I mean, the point, like x equals 2 is a very cool point, right? Because 2 minus 1, or actually no, you want this to be log of 1. I think you would want to choose x equals 5. Yeah, look at x equals 5. I would say x equals 5 because 5 minus 1 is 4. Quarter of 4 is 1. Then log of 1 is 0. So 5, y equals 3. That's a really good point to look at here. I assume f of x. Yeah, we're not given f of x. But I assume f of x is just equal to the log of x. I assume that's what f of x is. Because then this is with all the transformations on it. Yeah. Determine the equation of this graph. This is another, I think this is negative. Okay, so wait. Log of x. Log of x looks like this, right? Where log of 1 is 0. Yeah, there you go. This is log of x. Right? So this has been shifted over by 2. So let's say this is y is equal to log of x. The red one is definitely being shifted over to the right by 2. So I would say this is log of x plus 2. Well, sorry, minus 2. It's also flipped vertically, so I would put a minus sign on it. And then what else do we need? Maybe this is probably a useful point, right? Actually, this one's probably useful. Yeah, so this is 6 comma negative 1. So that'll kind of help here. So we could say this is log base 2. So that when you get 6 minus 2, you get 4. And log base 2 of 4 is 2. So then you get minus 2. Oh, so then this is great. And then you just say plus 1. I think this is kind of the way to do it, right? Fembox. Which is, it's the same thing as, like, changing the base here is the same thing as putting a multiplier on the front. Because log base a of b is the same thing as, like, log of b over log of a. Which is the same thing as, like, right, 1 over log a times log of b. So then this is kind of like the multiplier. So when you change the base here, you change this, which means you change this, so you basically have a vertical multiplier that's happening. Yeah, so this is a key point. Sorry, this is a key point. This is another key point. 3 comma 0. Oh, which I guess doesn't work with here, right? 3 minus 2 is 1. Oh, no. That's 0. I need that to be 0. Shit. Oh, no, no, no. How would you figure that out? I think, okay, wait. 3, 0 is a point. 6, -1 is a point. So I'm going to say this is, I know this has to be negative a log of something, right? Log of x minus 2 plus b. Yeah, maybe multiply 1/2 instead of adding 1. The way to do this, right? Okay, let's assume this is log base 2, because I think log base 2 makes things nice, especially with the 6 hitting and the 3 hitting. Yeah. Okay, so let's assume this is what it is. So then you plug in points. So I know 0 is equal to negative a log base 2 of 1 plus b. See, that tells me that b has to be 0, right? So here, b must equal to 0. Oh, okay. Yes. And then if this is negative 1 is equal to negative a log base 2 of 4. Yes. This is 2. So you just put a 1/2 on it. Yeah, 1/2 times 2. Okay, good, great. Yeah, yep. You were totally right, Fembox. So there you go. That's it. This is the equation. Very cool.
Oh, yeah.
Does that make sense, Pineapple? Makes sense how it works? Once you have the points, it's just setting up a systems of equations and just doing the two of them. Okay, nice. Cool questions. I appreciate it. All right. Let's mark Pineapple's done. I'll put another 15 minutes on the clock for you guys. Then I do need to eat something. I'm starving. Where's my calendar? There you go. You really need help with 1B? What? Oh, with doing the graphing? I mean, you should just graph it. I mean, I think you just have to graph this, which you could plug in some values, right? You do like x equals 1. Or x equals 10. Yeah, it's just a normal graph. Yeah. And then you just show like what the shift would be. So in this case, it's just shifted to the right one. It's up 3. So I mean these are the key things. You have x equals 5, y equals 3. So like 1, 2, 3, 4, 5, 1, 2, 3. And then the minus 2 means it does something like this. I believe they want the table thing where you do kx plus d and ay plus c. Oh. I haven't seen that before, but I mean, I guess that kind of makes sense. Right? This would be this. This would be whatever, like, g of x is. And then f of x would just be this. Or, sorry, it would be like this. This right here, this is here is like 1, 0. And then this is 5, 3. That's the key thing. You want to find the points where this whole thing goes away, because you're taking the log of 1, and the log of 1 is 0, and then this is your y coordinate. And then from there, you know that your asymptote is at 1, so then you can just do this, and your teacher should be happy with that. And then log of x is just an asymptote at x equals 0 that goes straight down, and just make sure it passes through 1, 0. That's the important thing. Those when they talk about like a table of values to communicate the process. I think just include the 1 0 point for the regular one, and then 5 3 for the g of x, the other one. That's the way you want to do it. Here, I'll put that graph in there for you. I don't know, that's kind of like, this one was more fun. I really like this. This is like trying to like figure stuff out. Like reverse engineering stuff. Okay. Does that help you out, Lucky Cat? Yeah? Also, yeah, you can just always graph it like this, bro. Yes, okay, cool. Alright, let's go spin. Who we got? Who's next?
Let's go gambling!
You're welcome. Rex. Means Trig Boy, dude, you gotta be next. 31%. I'm pretty sure you're gonna be next. I mean, this is probably this is a one-liner question right here. Select the function for which the Laplace transform does not exist. Yeah, where's Mean Machine Rex? I haven't seen Rex in a bit. I don't know. When did Laplace transforms not exist? I guess when the integral is unbounded, right?
Yeah.
Right? So let's remember like what a Laplace transform is. Okay. Oh, okay. So it's f of t e to the negative s. Or, sorry, I should have just wrote that down. What's up, Rex? Good to see you. So yeah, I think when this is unbounded is when you have issues. Okay. I want to say this one.
No. It's not that one. Because, if you think about it, the Fourier transform is a special case of the Laplace transform.
But I would have e to the t squared e to the minus st. Oh, yeah, dt, right?
But we know that we have a Fourier transform for a what's it called?
But how does that work? How is that bounded? How is e to the t squared bounded?
Oh, you're right. You're right. It is that. I think that is unbounded. Right? I was thinking negative t squared.
Yeah, I think the fourth one's the only one that's fucked. Right? This one's okay because that's t e to the t minus st, and I guess there's a world where this goes to 0 before this goes to infinity. This is more problems for the poor t. And then, yeah, log of e to the t grows slower than t, I think. So, yeah. I think just the fourth one. Cool. Okay, Rex. I think it's the fourth one. Just because t squared grows greater than t. And so you wouldn't be able to... Right, and log of e to the t, if it's ln of e to the t, is just t. Right, and so it's the same thing. Yeah, so in general, right, I mean, the ordering of things, right, x to the x grows faster than x factorial, which grows faster than a to the x, which grows faster than x to the a, which grows faster than x, which grows faster than log of x. So you're just comparing, like, which thing is going to beat out, in this case, e to the negative t, which is the same, e to the negative st, which is the same thing as 1 over e to the st. And so in order for this to be finite, this is where, like, if you remember from, like, calculus, like, convergence and limits and stuff, you need something that grows bigger than this. And so, yeah, the other ones do. Or this one does. If you want it to not converge. E to the t squared will always be bigger than e to the t, e to the st, yeah, or just e to the t. But then if these are the same order of t, right, such as this one, could be close. This is e to the minus t, which is much less. Do I stream 3 hours every day? I try to. Anyways, good job, good job. This was a fun one, Rex. Appreciate it. I might need to change that because I'm getting a little stretched thin at my other job as well, doing this on top. I'm starting to see like 2 hours is kind of like the sweet spot. Really, what I want is I want other people to stream. Like I'm looking at breasticles.
Once I get moved in.
Okay, so once breasticles start streaming, I will probably start decreasing my streams to 2 hours, just because I'm finding I'm getting a little stressed out with all the other stuff I have to do, and my other job is about to start really ramping up. Yes, of course. So no, I always find time to stream for you guys. It's just I might have to shift some schedules and trim some stuff. Especially during the summer. Yeah, when I'm teaching at UCLA, yeah, I can't do 3 hours every day. It's a lot. But other opportunities for other people to stream, which I would love to support and like send audiences to. Okay, trigonometry boy, dude, it's got to be you, right? This has to be your moment, right? This has to be you.
Let's go gambling!
I will stream my lectures at UCLA. It's Unlucky Dog. But I don't think we're counting Unlucky Dog's question. Yeah. This is brilliant, but I'm not doing this.
Aw, dang it.
Okay, I'm gonna mark that one as done. It's just like, I'm not doing it. Sorry. Alright, let's do it again. Do it again. You might have another shot here.
Let's go gambling!
Come on, trigonometry boy. I'm rooting for you, dude. And it's you! There you go. There you go. Alright, which one did Trig Boy say they need help with? Was it 6? Was it A, B, or C or something? Wait, what chat were you in? I forgot. Oh, you did tell me in one of your chats. Which chat were you in? Okay.
I think it was TikTok.
It was TikTok, you're right. It was Edvin. What did you need help with? Where did you say it, Edvin? Where'd you go, Edvin? Forgot which one. I do love the ratio test. Okay. If Edvin comes back, I think it was C, right? Do you think it was C? Was C the one? C the one they needed help with? These actually aren't bad anyways. Fuck it, dude. I think we can just do all three. Yeah, okay. So this one I can do by alternating series. Because of the -1. The -1 means it flip-flops, and so all I have to show is that this thing is always less than 1. Okay. So as long as I don't know, we say like an plus 1 is less than an, we converge. So in that case, I need x plus 1 over 2 all to the n to be less than 1. Exactly, right. Okay. Or the absolute value of it, Jeff, right? Right? So, okay, so x plus 1 absolute value has to be less than 2. So x plus 1 is less than 2, or x plus 1 is greater than -2. I think that's how it works. Yeah. Okay, cool. So x is going to be between -3 and 1.
Good job.
So interesting, that's the interval of convergence, but the radius of convergence locks in. What's that, Winklebot? The radius of convergence is equal to 2. Not sure about the lower bound. Yeah, because it reflips the sign Yeah, but it does reflip the sign, but it's not every single one, right? This is actually good. This is a good question for ChatGPT, actually. Let's send this one to chat. Okay,
I think the bounds check out. Because at -3, the 2 over ends would cancel, so then it would start flip-flopping and it wouldn't converge.
Oh, I see. Check the endpoints.
Yeah, well, but as long as it's not equal to -3, it should be fine.
As long as it's not equal to -3. Oh yeah. Of course. Yeah, because if it's actually equal to it, then it's just equal to 1. Oh, Don's great. We love Don. Yeah, my bearded friend. Or fellow bearded friend. Yeah, we love Don. Okay, raise the convergences too. There you go. Great. Alright. This one. Fascinating. So we were just talking about this, right? Right, what grows faster? Does x to the n grow faster, or n to the x, I guess, right? Or n to the whatever. So no, the n's can't be included, Winklebot, just because I need this thing to be less than 1. So we 100% don't include the endpoints just by the definition of just trying to make sure that these terms keep decreasing. I think the question was whether -1 is okay. For instance, like if I were to put -1 in for x, well, that'd be 0. Okay, so, or like -2, for instance. Let's say x was equal to -2. Yeah, Jeff says if we put -2, then you would get -1 to the n, which would cancel out this -1 to the n. Okay, but then you have the series of 1/2 to the n, right? And 1/2 to the n does converge, right? So long as this is less, that's by the p series. Okay, sorry for this
the
one.
-1 does make me question our lower bound though.
I think it's okay just by p series.
No, yeah. Sorry, I forgot it was multiplying.
Yeah, it's alternating series on the right, and then and it's geometric series on the left. Correct. I agree. Yeah. So we can say alternating series, geometric p series, the p test.
Yeah. Well, I was thinking right at when it's equal to 0 that I was like, oh, then there's just a -1 to the end. But
yeah,
it was just because I forgot to distribute the 0.
Now here, I don't think this ever converges unless x equals 0. Or I think this is also the same thing. I think x has to be between -1 and 1. Yeah, x equals 1 works. For okay.
Yeah, I think it's got to be between 1 and -1.
Yeah, this one needs to be between -1 and 1. But I think it does work. Geometric and p series. Isn't it not called the p test?
The p series is the 1 over. I can't remember if it's p to the n or n to the p. But
oh yeah. I see. Yeah, no, they are different. Sorry. Yeah. Okay. The other one. Yeah. Okay. To do this one, we could do the ratio test. I do like the ratio test. Let's fuck it. Let's just do it. Ratio test. So that's x to the n plus 1.
Line for the saying if we do the same test as last time, it's just
for alternating series. Yeah, p series is 1 over n to the p. Yeah, let's just try this. I'm just curious about this because right, and then this is the limit as n approaches infinity. So x to the n plus 1 over x to the n, that just becomes is equal to x, and then n squared over n plus 1 squared is just equal to 1, right? Okay, and then so the ratio test I think needs to be less than 1. this is it. Well, I don't. I like this one. Yeah. Yep. Yeah, sorry, it's the absolute value of this, right? So then it's absolute value of x times 1, right? And so we need this to be less than 1. So absolute value of x is less than 1. X is between -1 and 1. And you don't count the endpoints. I don't think. Or maybe you do, actually. Wait, the endpoints do work here, actually, right?
In this case, yes. Yeah.
In this case, endpoints do work. Yeah. Okay, very cool. But check endpoints. Exactly. Yeah, sorry. Yeah, it's inconclusive. Okay, so this is what we should... Yeah, I got you. Yeah, by the definition of the ratio test, we don't know what it is at the endpoint, so we should check them. And yeah, that gets you -1 to the n over 2 to the n. This is the same thing, right? This is -1 to the n, 1/2 to the n. Good. That converges, alternating series. And then the regular one, just 1 over 2 to the n, also converges. Was it n squared? Oh, it was over n squared. My bad. Sorry. It's the same thing, though. I'm getting all my things messed up. There you go. It's the same thing. It's just this is the P series, maybe. N squared equals 2 to the n. When it's on the bottom, yeah. Sure. Yeah. When my numerator, Jeff, is a 1, I give like 2 shits whether this is n squared or 2 to the n. It's still fucking huge. Okay. Okay, so this one does. So this one would be -1, 1. What if it's just n? Well, then it would work for the -1, but it wouldn't work for the +1. I agree, Jeff.
It's just n. I don't think it would converge if it's just n.
If it was -n, if it was negative, it would converge on one of the sides though. By alternating series, it would. The left side would, but the right side wouldn't. Conditional, yes, exactly. I'm pretty sure this is gonna be the same thing, right? We're just gonna say from -1 to 1. Because what are we gonna get?
I think that's everywhere.
I think that is actually. Sorry. Yeah, n factorial is much bigger than x to the n, right? We talked about that here. This is much bigger than this. So yeah, if you do the ratio test, you get that's gonna be x n plus 1 over n plus 1 factorial, and then we're gonna have n factorial over x to the n. That's gonna give me x over n plus 1, and then the limit as n approaches infinity, always gonna be 0. Cool. So this is -infinity, common infinity. Everywhere. Nice. Okay. Cool. Good question, Evan.
That's dope.
N factorial is bigger than all. Yes. The only thing n factorial is not bigger than is x to the x. That's the key one. All right, this was Trigboy 67.
Nice.
Cool. Okay, now I'm like really over time. These were fun though. Thank you, Trigboy, for waiting whatever the hour, whatever you waited, but it's there. Did you see it, Edvin? Edvin, did you see the solution? So also, if you're watching, and maybe you relate to it, make sure go to our website, actualofficehours.com. So where you went to go submit things, there you can click to join our Discord. And so what happens, Edvin, is every time we do a question, it gets put into our Discord here under homework help, and then you'll see it with your name here. Here's a solution, and then there's a link to the recording of like what we did. It's okay, Edvin. Yeah, you can always click here after the stream ends, and it'll go back to the exact point in the stream that we did it, and so you can kind of scroll through and see what we had. If you have any other questions about it, you can also like type in your questions here at the bottom. Also, if you join our Discord, you get what we call like bond coins. So you get credit for every question you ask. And so if you join our Discord and go react to that thing, I'll make sure your account gets credit for it. Yeah, you're very welcome. Okay, awesome. Yes. All right. So that being said, let's close out the stream, and yeah, cool. All right. Thank you everyone for coming to Actual Education Office Hours. Appreciate all the questions. You guys are dope. Thank you, Fembox. Knocked it out of park. I feel like I got knocked out of some sort of park with some of those questions. It's okay. Lots of fun. All right. So again, go check our streaming calendar if you want to see the stuff that's going on. We are going to have recess games. We're going to play Rocket League on Friday. So if you want to come by, go check out our sister channel, Actual Gaming. We'll give out gift cards to anyone that participates. And then I'll put this on Saturday. I'll make an announcement in the Discord. But I am going to be on another person's stream doing a little interview about the nonprofit, everything we do, you guys, and like my opinions on education. So come on by for that. It'll be fun. That being said, let's go raid someone. Let's go say hi to someone on Twitch. Who are we going to go say hi to? Nerduino's doing science. We just said hi to them. Is anyone else doing science I haven't said hi to in a while? Let's get Dr. Inez to Singapore. Fine. Wait, what? I know this girl. I met her at TwitchCon. She does stuff with like, well, they're doing like Twister. I don't know about that. That is some thought girl activities going on. Sorry, what? Inez. I guess it's one way to raise money. Physics and depression. There we go. There is some wholesome content for you guys. Okay, go say hi to Physics and Depression for me. All right. Enjoy the rest of your week. We will see you on Friday for games, Saturday for the podcast, or we'll see you on Sunday. Help you out with homework. Peace.
My screen name is Physics and Depression, and I think that people like sometimes don't realize that it's not a joke, and it really is just, I mean, it's like, if people laugh at it, it's fine, but it's like, it's not strictly a joke. But then on top of that,